Okay, so today we're moving on. Topic 6.3 is the factored form of a quadratic function. So prior to today, we've been looking at quadratics in standard forms, like y is equal to ax squared plus bx plus c. Okay, today we're going to get into factored form, and on Thursday, I think on Thursday we're going to get the vertex form. Okay, but we'll get to that. We'll cross that bridge when we get there. Okay, so some review here. So we have standard form, so this is y is equal to ax squared plus bx plus c. So remember, a will tell us the direction of opening. We can kind of forget about b, but it's related to the axis of symmetry. And c is going to be our y-intercept. Okay, number 2 is vertex form. We kind of talked about this a little bit today. So y is equal to a x minus h squared plus k. So h is going to be the x coordinate of vertex, and k is going to be the y coordinate. So, sorry, this is h, and k is the y. Okay, and I'll show you what I mean there. So if we had a function, so this is for vertex form. So if we had it like y is equal to 1 over 2 x minus 1 squared plus 3. Okay, our vertex would be 1 and 3. Okay, so not to be like confused with that negative sign. That's just what the formula is. Okay, so if we have a positive value, or sorry, like a negative value for h, it's going to be a positive value, and then if it's a positive h, it's going to be a negative vertex. Okay, again, we'll talk more about that when we get there. And today we're going to be doing our factored form. So this is going to be helpful for us. So r and s, these are going to be the x-intercepts. So remember, the x-intercepts is where does it cross the x-axis, okay? And so to find our x-intercepts, we need to find conditions that will set y equal to 0, right? So remember, on our x-intercepts, it's going to be...
Y is always going to be 0.
Yeah, y is always going to be 0. Well said. I feel like you knew I was going to flub that up. So you're like, let me help you out. Okay, so in this case, so like when we're finding conditions that set y equal to 0, we're going to do that for each of these brackets. Okay,
so r would equal like 1 and s would equal 1?
Yeah, so in this case, so x plus r is equal to 0, right? So plus r. So x equals r, that would be our 1 intercept. Okay, and then for the second one, if we have x minus s equals 0, plus s to both sides, x equals s. Okay, so to find your x-intercepts, we're just going to set each of these brackets equal to 0 and solve for that. Okay? Neat. Okay, so using your calculator, go ahead and bust these out. So sketch the graph of 2x squared plus 14x plus 12. Okay, so looking at this quadratic equation, again, this is in standard form, ax squared plus bx plus c. Just from looking at this, we can tell that our y-intercept is going to be at 0 and 12. Okay, and then if you were to use the calculation functions on your calculator, you can find your other values. So we're gonna have a vertex at negative 3.5 and negative 12.5. So 2, 4, 6, 8, 10, 12. Question?
I was just talking to myself. I
Oh.
was wondering if I punched it.
4, 6, 8, 10, 12. That's all right. 12.5 and 1, 2. Oh, I gotta move it over. Oh, there. Okay, so that's my vertex right there. From my A value, it's a happy quadratic, so it's going to be moving up. And I've calculated my x-intercepts are 0, negative 1 and 0, yeah. And then negative 6 as well, so 1, 2, 3, 4, 5, 6.
Negative 6 and 0.
Perfect. So negative 6 and 0, and negative 1 and 0. Okay, vertex we have negative 3.5 and negative 12.5. And that's all that we're asked, right? So now I'll just try my best. Oh, I think I'm getting better.
Mine was terrible.
It's hard on paper. I find that your like pencil always like catches it and it's hard to make like a smooth grappa. I'm serious. That might be my best one ever. Okay. Now, when you guys are doing this, you should label your points of interest on here, right on the graph. Negative 6 and 0, negative 1 and 0. It's just good practice. Negative 3.5, negative 12.5. And then our last y-intercept is 0 and 12. Okay? So, at a minimum, you guys should be able to solve a problem like this using your graphic calculator. Okay? That's the new expectation at this point in the course. Okay? We should all know how to do this. And if you don't, come ask me for help. Okay? Okay, so now we are given a equation in factored form. Okay, so this is still going to be A. So we're still going to have a happy parabola. And then these are going to tell us our roots, right? So for our x-intercepts, we're just going to set each of these brackets equal to 0. So x plus 1, oh yeah, so we're doing this one without your graphing calculator, okay? We're doing this one just with our brain, what we know about factored form, okay? So we're going to set each one of these brackets equal to 0, okay? So x plus 1 equals 0. How am I going to get my x by itself? Well, I'll subtract 1 from both sides. X equals negative 1. So we have a point, negative 1 and 0. And then I'll do that for the second one as well. So x plus 6 is equal to 0. Minus 6, x equals minus 6. And that's another ordered pair. Yes?
Will we ever actually have to solve one of these without a calculator in a test?
Yes, you will. It's okay. Don't worry, we're going to get lots of practice today, and it's not too hard.
So we don't get a calculator for the quiz.
There might just be turn over your calculator for this question. Maybe I'll just make them both. No calculator, but no, because if you're given a question like this on a test, you may just be able to graphic, but you're gonna have to show your work. That's gonna be like the catch there, is that you have to show your work to get the marks. Okay, and it's not too hard. Okay, Maddie, do you have a question?
No.
Okay, cool. Okay, so we have x-intercepts at negative 1 and 0 and negative 6 and 0. So 1, 2, 3, 4, 5, 6. So negative 6, 0, and negative 1, 0. My y-intercept. What is true at my y-intercept? Always. Always.
X is 0.
X is equal to 0. Perfect. So now I will substitute in x equals 0 in this equation. So y is equal to 2, 0 plus 1 times 0 plus 6. So y is equal to 2 times 1 times 6. So 2 times 6 is 12. So
Y-intercept 0 and 12.
perfect, 0 and 12. So 2, 4, 6, 8, 10, 12. And what else do we need to know?
The vertex.
The vertex. Good. How do we calculate the vertex?
Isn't it just the y or the x?
Yeah, the x coordinates of the vertex, right?
-7.
-7. Where'd you get that number from?
I can just tell from looking at it.
So -1 and -6, right?
Oh shit, I was doing it 2, 4, 6, 8, 10.
Okay, yeah.
So
So
it'd be -3 then.
-3, right? Perfect. So is what we need to do first. So for our vertex, so remember, if we know two ordered pairs that have the same y value,
Yeah.
we can calculate the axis of symmetry using those two x coordinates, right?
Oh yeah.
So-
6 plus 1 divided by 2.
Yeah, so vertex, so x is equal to -6.
Oh, it would
Plus-
have to be, I guess, 6 times 1, because 6 plus 1.
So we just have to be careful with our negatives here, right? So we have -6 plus a -1 divided by 2 is equal to, so -6 plus -1 is
Seven.
-7 divided by 2 is negative
3.5.
3.5. Okay, so we know the x coordinate of our vertex is 3.5. 1, 2, 3. So about here somewhere. Okay, but what do we not know about our vertex?
Oh, how far down it goes?
Exactly, we don't know the y value, right? So at x is equal to 3.5, we can just substitute that into our original equation. Okay, so we'll do the same thing. So y is equal to 2 times -3.5. Sorry, that should be a plus. Plus 1 multiplied by -3.5 plus 6. So if you do that, I get -12.5. So there's my ordered pair right there. -3.5, -12.5. So 2, 4, 6, 8, 10, 12. So about here, I think. And now it's just time to connect the parabola. You guys notice anything about this one? They look similar?
Notice anything?
Yeah, it's the exact same deal.
Exact same
Oh.
as the other one, right? Same intercepts, same vertex, same everything, okay? So what do you notice? It is the same as the last graph. Fancy that, but it's just in a different form, right? So, and if you really didn't believe me, you're like, there's no way that was the same graph. You can just use your FOIL expansion here, right? So this goes in here and then here. So you get x squared plus 6x, right? Plus x is this one. And then 1 times 6 is plus 6. So 2x plus 7x plus 6. And then you get 2x plus 14x plus 12. And that's what we had in the first one, right? Yeah, 2x, oh, I forgot my squared. The whole way. There we go, that's better. 2x squared plus 14x plus 12. So, same graphs, just different way of presenting them, right? Cool. So, as we just said, 2x squared plus 14x plus 12 is the same as 2x plus 1 bracket x plus 6 bracket. Looking just at these two, what is the same in both equations? What is the only thing that you see in both? I guess we see x's. How about the a value? A value stays the same? A value is the same. And what could we use from the first equation to get us into the second equation? So our a value is going to be the same, right? So a value, and what are these? So in the factored form, what do these tell us? If I set them equal to 0, I can find the x-intercepts, okay? So if you're given this first and you want to go into this, all you really need is the a value and 2 x-intercepts. Okay? So to go from standard form to factored form, all we need is the a value and 2 x-intercepts. Okay? Yeah, so we can rewrite this general form into factored form by knowing the value of a and the values of the x-intercepts. Okay, so make sure you guys write these 2 points down in your notes right here. 1 and 2. Okay? Value of a and the value of the x-intercepts. Okay? So, to summarize what we talked about, y is equal to 2x squared plus 14x plus 12 can be rewritten as y is equal to 2 bracket x plus 1 bracket x plus 6. Since 2 is the a value, okay, that doesn't change, and the x-intercepts are -1 and -6. Okay? So be able to go from either standard form to factored form, or one way or the other. Okay? So, example 2. So write this in factored form. So when we're factoring, we need to know, or we need to take something that is common to every term in our equation. So what is something that we could factor out here?
X.
X? Do we have an x in this
Oh,
one?
no, never mind.
No, we don't. We don't, but we're close. We're close. Anything, what else? Could we take out a 1? We could, but would it change anything?
No.
No. 2? No. How about a 3?
Yeah, you could do a 3.
Yeah, and let's do a -3. So then we get a positive x, okay? So factored form, so y is equal to -3 bracket, okay? -3. If we're taking a -3 out of -3x squared, we will be left with x squared. If we take -3 out of 6x, we will be left with -2x. And if we take a -3 out of a -3, we'll have a +1. Right? Yeah, so then we need to ask ourselves here, what will give us a product of +1, but a sum of -2? What numbers can we multiply together that will give us a positive product, but a negative sum? how about we do x minus 1 and x minus 1, right? If I multiply -1 by -1, I get +1. And then if I add -1 and -1, I get -2, right? Yeah, that one's kind of tricky, okay? So, what does this tell us? Factored form in the brackets. What does that tell us? Okay, make sure you guys write this down. So in factored form, whatever's in the brackets will be the x intercept. So I'm just going to write something. So in factored form, what is in the
X-intercept.
brackets will tell us the x-intercept when we set it equal to 0, right? So this guy here, I can actually simplify that.
Wait, what's that word after in factor form?
What
Oh,
is
it's factor form.
yeah, in factored
Oh,
form?
I thought it said factor for many.
No, sorry, I got a little
That's good.
carried away with that M. Okay, so in factored form, what is in the brackets will tell us what the x-intercept is when we set it equal to 0. So for example here, so x minus 1 is equal to 0. Well, if I just get x by itself, plus 1 on both sides, x equals 1 is our intercept. And when you see something like this, when it's like x minus 1 to the squared, when it's not like okay, when it's like this, you get 2 x-intercepts. How many x-intercepts do you think this has?
Well, I just have 2.
Just one. Just the one, yeah.
Oh, it's only one bracket.
Just the one, yeah, just the one bracket, right?
Okay.
So when you see something like this, it only has one x-intercept.
Yeah.
Okay, something like this will have 2. Okay, and remember, what 2 things do you need to go from standard form to factored form?
Value of A
Yeah,
and a value of your x, or 2 x-intercepts.
yeah, perfect. A value and 1 or 2 x-intercepts. So A value and x-intercepts. And I'll put that in bracket S because
Wait, 2 x-intercepts or just does it
1 or 2.
1 or 2, yeah. Sometimes they're actually not going to have any x-intercepts, but we will not be able to use factored form for that. That'll be vertex form, okay? Okay, so approximate the equation of this parabola in factored form, okay? So we'll do this one together, and then next one you guys will do on your own, okay? So approximate, okay? So we're just kind of going to use, we're going to use our brains to make a logical kind of assumption about what is going on here, okay? So we could just assume that our x and our y intercepts are going to be 0 and 9. We also have an axis of symmetry here, right? X equals 4.5. So we know that our x-intercepts are going to be 0 and 9, right? So x-intercepts, we have 0 and 0, and we also have 9 and 0. Okay? Now, is this a happy parabola?
No.
Sad.
Sad.
Sad parabola, okay? So we know we have a negative a. Okay? We know our x value. We know our x-intercepts. We know our axis of symmetry. We know our a value. Okay? So,
Y value is
yeah, so now we can just kind of get in there, right? So we have a y is equal to a. Okay, I know we know it's a negative a, but we will solve what the actual value of a is. So just leave it for positive right now, okay? So we have that, and we also have our x-intercepts. So it's x minus 0 and x minus 9, right? So remember, this value, when you set that equal to 0, that's when you can find that, right? So x minus 9 equals 0. Okay, for your one intercept, right? If you had that and you went the other way, okay? So we know that. So after we have it set up, so this is in factored form. Now to find our a value, we can substitute an ordered pair, a known ordered pair, find a value, we can substitute a known ordered pair into our formula. Okay, so what is a good ordered pair we could use here? I want this guy right here. One and 8. So I will substitute in 1 for x and 8 for y. Okay, so y is equal to a x minus 0, x minus 9 at 1 comma 8. That's my ordered pair. So 8 is equal to a 1 minus 0, 1 minus 9. And I know you guys will just use your graphing calculators to do this, right? To solve. I'm old school. 1 minus 9 is negative 8. Yeah, so negative 8 times positive 1 is negative 8. So I'll divide by negative 8 on both sides. And then 8 divided by negative 8 is
0. Or 8 divided by... Oh, 8 divided by negative 8 is... I don't know.
negative 1. Negative 1. Okay, any number divided by itself is going to be 1, always. Okay, so now that we have our a value and we have our x-intercepts, we can finalize our answer here. Okay, so we have y is equal to negative 1, that's our a value, and then we can put in our roots. X minus 0, x minus 9, okay, x minus 0 is just going to be x minus 9, okay, and then I'm going to simplify this. Negative 1 times x is going to be negative x minus 9. Final answer. Okay, so from our graph, we can tell we have x-intercepts at -1 and 0, and +4 and 0. Okay, so from there we can go y is equal to a. So of x-intercept of -1, that's going to look like x minus 1, right? Because we need our x to make whatever's in the bracket equal to 0, right? So that's what that looks like, x minus 1. And then we're going to have x minus 4 here as well. This should actually be x plus 1 and x minus 4.
Every girl just has a like in her locker. I'm not sure.
X plus 1 and x minus 4. Okay, and again, if these brackets are kind of messing you up, or the x-intercepts, just remember, so we have to do x, hey, we have to do x plus 1 is equal to 0. We're going to set each of these brackets equal to 0, right? So x plus 1 minus 1, x equals minus 1. That's our 1-intercept. Okay? And then x minus 4 is equal to 0, 4, x equals 4. Okay? That's how we get these values here. X plus 1 and x minus 4. Okay? Okay, so now that we have our x-intercepts, we need to find, so that's step number 1, is find your x-intercepts, okay? Step 2, we're going to write it in factored form, which we did. Step 3, we're going to find A by subbing in a known ordered pair. So I like this one right here. 1, 2, 3, 4, 5, 6. Okay, I like that. It's a nice one. So now we'll substitute at 0, 6. So this is x and or y. So I'll have 6 is equal to a, 0 plus 1, 0 minus 4. 6 is equal to a, 1 minus 4. 1 times -4 is -4. So a is equal to -3/2 or -1.5. Fractions or decimals? What do you guys prefer? Decimals?
Yeah, definitely.
Decimals? Okay. So that gives us an a of -1.5. Okay, so now we can just rewrite our formula. So y is equal to -1.5, x plus 1, x minus 4. And that's it. And could we go from factored form to standard form? The answer is yes, we absolutely can. We just need to expand our brackets and then distribute the 1.5 in. So you don't have to, but I just want to show you guys how you can easily go from factored form to our standard form. Okay, so we'll keep -1.5 outside. Then we have x squared minus 4x plus x minus 4. So -4x plus x. -4x plus x is -3x minus 4. Now I need to put this in. So y will equal -1.5 x squared plus 3 times 1.5 is 4.5. Yeah. It is 4.5x. And then negative 4 times negative 1.5 turns into positive 6.
Wait, did you say 1.5 squared is 4.5?
No, sorry. Negative 1.5 multiplied by
Oh.
4 is positive 6. So this is in standard form. And up here, factored form. Okay, for the next one, I want you guys to try this on your own, please. So this only has one x-intercept, okay? Determine its equation in standard form. Okay, so step 1, we need to find our x-intercepts. Okay, this one we only have 1, which is right here. So it's negative 1 and 0. Okay, if there's only 1, remember we put like this squared exponent on the factored. So we'll go y is equal to a
X plus 1
x
squared.
plus 1 squared. Okay, and again, we need this x equals negative 1. Okay, so that's how we get that one. It has to be the opposite there. Okay, so we found x-intercept. Step 2 was writing it in our factored form. Step 3, we need to find a by substituting in a known ordered pair. So I'm going to use 0 and negative 1. So this is my x, that's my y. So I'll have negative 1 is equal to a 0 plus 1 squared. Okay, I'm not doing anything to the equation except for swapping or substituting in my ordered pair at 0 and 1. Okay, so negative 1 is y and x is 0. So now I'll just solve for a. So 0 plus 1 is 1. And 1 squared is still 1. So negative 1 is there. Is equal to a. So 1 squared is 1. So I just have a1 divided by 1 by 1. A is equal to negative 1. Okay, now that I have my a value and my factored form, I'm just going to do my last step here and write my equation again. So step 4, we have y is equal to negative 1, and then we had our x plus 1 squared. And we can simplify that to y is equal to negative x plus 1 squared. How'd you guys do? Did you get that? Yeah? Logan, how'd you do?
Yeah, I got it.
Yeah? Brody? You're good? Perfect. Or just keep on trucking. Okay, so parabola has x-intercepts at negative 3 and 1/2. It has a y-intercept at 4. Determine its equation in Okay, so for this one, we know that parabola has x-intercepts at negative 3 and 1/2. So remember on our x-intercepts, our y values are always 0. Okay, so that means we have a point of negative 3 and 0, and 0.5 and 0. Okay, We also have a y-intercept at +4. So at the y-intercept, we have an x value of 0, okay? So 0 and 4 is going to be our other point, but other than that, we don't know anything, okay? But that's okay, because we know our x-intercepts, and we know one ordered pair, so we can calculate a factored form equation, or we could even put it in standard form if you want. But we'll just leave it a factored form for today, okay? So factored form, y is equal to a, and then you have like x minus r and x minus h. So in this case, I have x plus 3, right? Because negative 3 plus 3 is equal to 0. And then I also have x minus 0.5, okay? 0.5 minus 0.5 is equal to 0, okay? So that is my factored form. Okay, now I will substitute in my known ordered pair. So I'm going to substitute that in at 0 and 4. Remember, this is x and y. So then we'll just go 4 is equal to a 0 plus 3, 0 minus 0.5. Do you guys see now why I like to use the simplest ordered pair, right? Because then half the time you don't even have to do operations, right? Anyways, so 4 is equal to a times 3 times negative 0.5. 3 times negative half is negative 1.5. So I'll get rid of that, divided by negative 1.5. And
What that equals.
what did I do? Oh, there it is. 4 divided by negative 1.5.
2.6 repeating.
What did you get?
2.6 repeating.
Okay, yeah, perfect. So negative 2.7 if we round up. Or if you're a fraction person, negative 8 over 3. Okay, so now that we know our a value, we can just, so this was step 1 and 2. This was step 3. And now for step 4. Write a new equation and simplify. So y is equal to negative 2.7 bracket x plus 3, x minus 0.5. Yeah. Or if you're a fraction, is there any fraction people in here? Are we all like decimals?
All decimals.
Yeah. Okay. Well, if you do like fractions, I kind of like fractions, to be honest. So, or negative 8 over 3, x plus 3, x minus 1 over 2.
How do you know that? Like, how do you know that negative 2.7 is negative 8 over 3?
I don't personally.
Oh.
Okay, so example 7, we are given an equation in factored form. So we're gonna sketch it. We know from our x-intercepts, so what is gonna set this equal to 0? So x minus 2 equals 0, plus 2, x equals 2. So that is 1 x-intercept is 2 comma 0. And then what sets this one equal to 0? So x plus 1 equals 0, minus 1, x equals minus 1. So my other x-intercept is negative 1 and 0. Okay, so I'll plot those. So we have 2 and negative 1 and 0. What else? Axis of symmetry. How would I calculate that? Logan?
Oh, calculator? Well, I just found it on here. Sorry.
Okay, so for something like this, you're not going to be able to use your calculator. Okay? When it's in factored form, you just got to use your brain. Okay? So we found our x-intercepts from this. Now, how am I going to find my axis of symmetry?
Oh, you just take 2 times, or take 2 plus negative 1 divided by 2.
Perfect. So we're going to take the average between our x-intercepts. Very good. So x is equal to 2 plus negative 1 divided by 2. So it'd be 1 over 2. So half.
Yeah.
So somewhere around there, which is good. I'm happy about that. Looks about right, hey?
Yeah.
It's not very symmetrical. Okay, so axis of symmetry, but didn't need anyways, x equals, well, 1 over 2. I should put the right out there, but that's fine. Okay, and now if we know that our x is equal to 1/2, we can find our y value of our axis of symmetry. Or we just need to find the axis of symmetry. We don't need to find the vertex. We should probably find the vertex. Yeah, we should find the vertex. Okay, so we'll just substitute in x is equal to 1/2 into that. So y is equal to 0.5 minus 2 times 0.5 plus 1. So y is equal to 2 times negative 1.5 times 1.5. Can somebody do that? Oh no, I got that. Y is equal to negative 4.5. Okay, so my axis of symmetry, or my vertex, will be 0.5 and negative 4.5. 0.5 and negative 4.5, so go up there. Okay, and what's last? My y-intercept. What do we know at the y-intercept?
X is going to be 0.
X is going to be 0. Very good. Okay, make sure you know that. That's very important. Okay. X equals 0 at the y-intercept, so we'll just do, now we'll just find the y-coordinate of that. So 2, 0 minus 2, 0 plus 1. Y is equal to 2 times minus 2
Which is
times
1.
plus 1.
Times 1 is 1.
2 times negative 2,
Is
negative 4. Right? 2 times
Oh,
negative 2 is
shit,
negative
yeah.
4 times 1 is still negative 4. So my y-intercept is going to be 0, comma, negative 4. Which is right here. Oh, it was starting out right. Not my worst, not my best. Okay, so we will leave it at that for today.